Everyone, and welcome to another lesson. So today we're on chapter 3, section 3, part 2. So we're finishing up the things we talked about. We started to talk about last time, all different things about slope, looking at inclines, how these things change, and what they mean in different contexts. So we'll see that in some problems coming up. We did the first 3 type of examples, and today we're going to work on the last 3 types of examples that we'll see. We'll see a lot of order pairs. We'll see some coordinate plane work. We'll use that rate of change and that slope to solve some problems. And of course, we'll find the slope of a line in these examples as well. It's the same vocabulary as last time. We talked about the rate of change being the change in y over the change in x. So it's always the vertical over the horizontal. Another way to think of that is rise over run. So keep that in the back of your head as we look at some of these problems. So 3b, this is just review from last time. We want to look at this problem and determine, is this whole thing representative of a line? So if we graph all these points, would there be a line? Well, how do we find that? Well, we have to track the way each variable changes. So x from 3 to 6, we get an increase of 3. From 6 to 12, we get an increase of 6. From 12 to 15, another increase of 3. Let's look at our y's. We see here an increase of 4, an increase of 4 again, and from 20 to 24, an increase of 4 one more time. So the y is always changing by the same amount, so that's okay. But notice here the x's change by 6, and they also change by 3. That's not always the same. So we have all of this now. So to answer the question, we need to know, what does it mean for it to be linear? Well, all of these would have to be the same. The change in x always has to be the same number. Y always has to be the same number. In this case, the x is different there, so we know it cannot be constant. So anything that says yes is wrong. We know the rate of change is not constant. The rate of change is not constant. And why do we know that? Well, because the x changed by a different amount. So it's not the same, so we can stop there. No, this whole thing does not make a line. So that's just review from what we talked about last time. So looking at this depiction of slope, we've got our m is our slope variable. It's equal to the change in y, which with 2 points, the vertical change between 2 points is the difference between them. So you take one, subtract it from the other. y2 minus y1, 1y minus the other. That's what we see here. So that's the numerator for our slope formula. That's the change in y. By the same logic, the change in x is represented by the difference between the 2 x points. So here we've got one x, the other x. Subtract them. That gives you a number that goes in the denominator for our slope. And then we simplify that, and that's going to give us the slope of this line. So we don't even need a graph. If we use this slope formula, we'll be able to find the slope just given 2 points. So we could do that if they gave us a problem like that. And what do you know? Look at example 4. We're going to be dealing with positive, negative, and 0 slopes. They ask us find the slope of a line that goes through these 2 points. So given these 2 points, we can do that by using that formula we just talked about. So first, we can label our points. So we want one of these to be the 1s and one of these points to be the 2s. That's just saying which one are we going to start with, which one are we going to finish with when we subtract. So if we label this first point as our x1 and y1, the second one then becomes the 2s. So now we have to plug into our formula. This is our slope formula that we already have down. That's our rise over our run. And now to solve this whole thing, we just plug in the numbers. So y2, what is that random thing? Well, where's y2 in this whole thing? y2 is 5. We're going to subtract. What is y1? Well, y1 we said is 2. So 5 minus 2 on top. On the bottom, same thing. x2 is 5. x1, negative 3. 5 minus a negative 3. Now, the double negatives are going to be a problem if you're not good with that. Subtracting a negative is the same thing as adding. So 5 minus a negative 3 is the same as 5 plus 3, which we know is 8. So you get 3 on top, 8 on the bottom. That is the slope that goes through these two lines. It's the one and only answer for this type of problem. So there's your slope, and we found that using that formula. Easy enough. These problems are pretty quick. So 4b, same process. Given 2 points, find the slope. So first you want to label them. Which one do you want to be your 1s? Which one do you want to be your 2s? So you know which one you're going to start with in your formula. So we say this one's going to be our 1s, this point's going to be our 2s, and now we just substitute in. So we say what those things are. y2 negative 8 minus negative 4. Good. x2 is a negative 2 minus a negative 3. Good. So remembering subtracting a negative is the same as adding, you should change this to negative 8 plus 4 and negative 2 plus 3, and then add those. So if you're really bad with adding negative integers, you're going to have to practice that to be able to do these problems. So negative 8 add 4, you get a negative 4. Negative 2 add 3, you get a positive 1. Negative 4 over 1 is just a negative 4. And we are done with that, with just those couple steps. Slope, negative 4. Okay, so the third problem for this type of example, given 2 points, we want to find that slope again. So we label them. We can say this is the 1 since it comes first, easy enough. This one is the 2s. You can label them either way. So this 4, 4 could be x1, y1, or x2, y2. It doesn't matter which one you label it as long as you keep it straight. So we'll start and label this one our 2s, this one our 1s, and plug in just like we just did on the last one. We'll get our rise over our run. So m is going to be the difference in the y's, 4 minus 4. The run is going to be the difference in our x's, 4 minus a negative 3. So that gives us this whole expression. We know we get 0 on top. That's easy. And 4 plus 3 is 7. So 0 divided by 7 is just that value of 0. So it's okay to have 0 in the numerator, but you can't have 0 in the denominator, and we're going to talk about that as we work forward. But for this one, the slope is just 0. It is a flat slope, no incline. Okay, so 4D, we can work through this using that formula. Find the slope given these points. So say I call this one x1, y1, and this one's going to be my 2s. Now those numbers are not numbers we're doing any operations with. That just helps us know which one comes where in our formula. So m equals y2 minus y1 over x2 minus x1. So let's plug in now. The difference in our y's is going to be 6 minus 5. The difference in our x's, 7 minus 4. So here we'll get 1/3 as our slope. Just like that. Our answer is C. Okay, so the fifth type of example is going to be all about some slopes that are undefined. And undefined means when you divide by 0. So let's see what that problem would look like. Finding the slope of these 2 points. Label them like we have before. So here's our first one. Here's our 2s. And then we'll subtract and simplify. So y2 minus y1 in this case is going to be 3 minus a negative 4. That's 7, which is okay. Our x's are going to be negative 2 minus a negative 2, which is negative 2 add 2. That comes out to 0. Now this thing is a problem. You can never divide by 0 in math. It's almost like it would equal an infinite number. So it's like it's an error anytime you see that. You cannot divide by 0. So that is an undefined slope. It's really a line that's perfectly vertical. But for the purposes of this example, it's undefined. That is the answer. That is the word we use when you divide by 0. Undefined. This is not 0. This is undefined. That's going to be a common mistake. So there you have it. Since you divided by 0, which is not allowed, slope is undefined. So you'll see one or two like that. Now this is a useful image just to visualize what the slope should look like. So positive slope always goes up to the right. Negative goes up to the left. We know 0 is flat, horizontal. Undefined is a perfectly vertical line. So keep that in the back of your mind as you graph and practice these problems. This will be very useful to know as you work forward in the rest of your career in math and sciences and college and anything you plan to do. Okay, sixth type of example. These are interesting problems, but all we do is use the same formula we've already done, and it's just like every other problem. They give you all the numbers you need, and they leave one out, and you have to find that missing thing. So it's a challenge, but it's easy if you plug in and then you just find what they didn't give you. So find the value of one of these numbers that's missing in our point right here, given the slope. So in the other problems, they gave us the points. We had to find the slope. Now we're working the other way. They give us the slope. We're missing one of the values of our point. So we can do this by starting with our formula. So notice there's 5 things in this formula. 2 y's are given, 2 x's given, and a slope. So before they gave us all 4 of these and said find m. Now they're giving us 3 of these and the slope and saying find which one of these is missing. So same process, plug everything in and then simplify to get your variable alone like we've been doing for a while now. So m, slope, 1/2, right there. We'd want to label our y's. So in this case, this is the y that's given first. So we'll do 2 minus 3 like you see there. 2 and 3, those are our y's. You'll divide, and then x2, what's missing is r, that's 1x. And you'll subtract what the other x is, 6. So this whole thing now gives us an equation we can use to now find what that r is. So we'd have to do some multiplication here to figure it out. So simplify the top here, you get -1. Now one more step. You find the cross product to get rid of all the fractioning. So you see here we have a proportion, we practice this. So you can now multiply 1 times this, multiply here, and then now we're closer to solving for our variable. So that gives us this cross product. 2 times -1 is a -2. This is 1 times this, doesn't change it. Add 6 to both sides, and r is 4. And that is done for that problem. We found that missing coordinate. This has to be the value of the missing x in order for that line to have a slope of 1/2. So these problems are not lengthy at all. These are very short problems, very quick. Okay, one more to look at. We want to find the value of p, this missing x in this ordered pair. They tell us the slope is 5/8. For some reason that got shifted. So slope of 5/8, what is that p value supposed to be? Well, we would plug into our formula. We know m equals y2 minus y1 over x2 minus x1. Okay, so given all those things, we can plug in and figure it out. So let's label these things. Say I'm going to call this one, these my 2's for this point, x2, y2. This one will be my 1's. And again, you can label these however you want. You just need to pick one point to have the 1's, one point to have the 2's. so you keep them in the right order. So now we just plug in. So y2, 4, minus y1, negative 1. So instead of writing 4 minus a negative 1, I'm just going to write 4 plus 1. And subtracting a negative is the same as adding. Now we do x2, which is p, minus x1 is 3. And what does m equal? Well, we said m equals 5/8. So this whole thing has to equal 5/8. So in this case, we could now simplify, find the cross products, and solve for this answer. And if you were to simplify this, 4 plus 1 we know is 5 over p minus 3 equals 5/8. And if you can't see the answer, you could just do 1 or 2 more steps to solve for that variable, and you would find p in this example, just like in the last one, solving it, would have to be a negative 5. Because our slope here and the formatting's a little bit off, but this is a negative 5/8. So if we were going to rewrite the way that formula should look, m equals y2 minus y1 over p minus 3. So this formula would give us, when you cross product and solve, p would have to be a negative 5. So this is the hardest of the type of problems we'll have to do today, but you can do that with just a few steps using your slope formula. You can figure that out, no problem. This slope formula is your best friend. Without it, you are lost. With it, you can solve these problems with no difficulties at all. So I want to see you on task, working with this, practicing these concepts. I'm very confident in your ability to do this. Let's get started.